evolution of human civilization sees the sudden turns when it strikes with new idea. It changes the world as it was never before. Every new idea brings revolution and changes the very face of life. Recently, such a revolution is struck to manufacturing and changed the basic idea of manufacturing from subtractive to additive. Introducing LAM, Laser Additive Manufacturing, a technology that revolutionized with a new idea called feature-based design and manufacturing. LAM is propelled with advanced technology of high-power lasers, computer-aided design and manufacturing, powder metallurgy and allied electronics, and translates 3D models into 3D functional parts. It starts with a 3D model which is obtained either by 3D imaging system or by CAD software or by CAD software or by numerical analysis data and sliced into thin layers along the vertical axis. These thin layers are converted into corresponding numerical control code and sent to LAM station. LAM station employs a laser beam as a heat source to melt a thin layer on the surface of the substrate deposited material and feed material to deposit a new layer as per the shape and dimensions defined in numerical controlled code. A number of such layers deposited one over another and thus 3D component is built. A team of engineers and scientists at RRCAT, a premier R&D institute under Department of Atomic Energy, Government of India, took a task to tap the tremendous potential of this technology for improving the qualities of product, possibilities to make integrated multi-materials and multifunctional components, and enhancing economic or procedural benefits to automotive, nuclear, naval, aerospace, medical and other engineering industries. RRCAT developed a 2 kW fiber laser-based LAM system and being deployed for making complex engineering components for various applications. One of the exciting application of LAM technology is fabrication of honeycomb-shaped orifice grid plates developed for fast breeder reactor program. These plates are used as pressure drop devices, facilitating for appropriate liquid sodium coolant flow in the reactor. LAM increased the useful life of valve spools by depositing high-performance material Triboloy 700. LAM technology opened new avenues of joining metallurgically incompatible materials like stainless steel with titanium. It is done by appropriate grading of friendly material layers sandwiched between the two metallurgical incompatible materials. Another good application is fabrication of low-cost tools using LAM. Because of high cost, tungsten carbide inserts are used in large size tools. But it is not possible to use inserts for smaller size tools. Therefore, solid bars are used for making small tools. LAM is used to deposit selectively tungsten carbide on low-cost material, converting it to low-cost tools. LAM technology has provided 5 exclusive freedom to human race for the fabrication of components. 1. Material design freedom. 2. Shape design freedom. 3. Logistics freedom. 4. Quality freedom. 5. post-processing freedom. It has revolutionized the concept of prosthetic fabrication. If someone meets an accident, his CT scanning is carried out. CT image is converted into a 3D model under the supervision of experts like biomedical engineers and surgeon, and model is sent for the fabrication on LAM machine. Prosthetic of desired shape and size is made and it is ready for transplantation. These steps are possible in amazing 48 hours. This is just the beginning of revolutionary technology, LAM. Much more to come by stretching the limit of possibilities to its extremes.
Welcome to you all. Yet another session on 3D Graphy News interview. Ladies and gentlemen, I'm sure you would be by now aware of the platform that we've been able to design. But still, in short, 3D Graphy is a platform that we've designed for events, and we've been conducting events for the last 8 years. And we've seen that with a consortium like 3D Graphy, it's actually given us a great opportunity to connect with 3D technology companies who have also been registered across different technologies, may it be DED or SLA or SLS or DMLS. So various technology respondents who have joined us from India and globally. And at the same time, we also have end users expecting what is the best solution that probably they would want to procure or want to start for their services, maybe for dental, medical, orthopedic, automotive, across sectors. And we have been conducting almost 43 events, and we have conducted almost 43 events in the last 8 years. And last 2 years we were really engaging. When I would say even in this COVID times, we found that virtual space has really gained a lot of traction. So today also I get the opportunity to connect with Dr. Paul, who is one of the research scientists from RRCAT. Thank you so much, sir, for your presence. So it's always been a conscious effort for us to connect with all the leaders and champions of this technology, made for research or development, material scientists, technology experts, doctors, surgeons, aeronautical engineers, and technology companies, and which are into scanning and software and simulation and 3D printers. So it gives us as an opportunity to connect chords with everybody, so that there is a pathway set in terms of what is expected finally. So here we have the 3D Graphy News, which is also a conscious effort. We've just launched it in 2022. But there was a pilot project that we've been running for the last 6 months, and we understood that communication should be interactive and it should be an ongoing exercise, because there's a lot of content which is probably need to go to the end user. So we thought, why not, with this 8 years of experience, build this news platform and now have a focused effort also for a communication panel, which will also ensure that respondents coming from various different domains of expertise can share case studies. We can also have research insights enlightened through this platform. Also spotlights, also events which will also be posted. It's a very innovative way. We'll also be sharing those details for all of you to also benefit the exercise. And also interviews and expert views will also help respondents to gain their bit of share of information for them to benefit from that information. Thank you so much once again, ladies and gentlemen. And now I quickly go to Dr. Paul, who is our key respondent today. Sir, thank you so much for your time, and also being in this space. And it is also our privilege to also have you as our editorial advisory board member from the research side. Thank you so much. In short, sir, where did it all start? How did 3D technology start from your area of expertise?
Yeah, see what is happening in RRCAT is identified as one of the centers working in the non-nuclear research areas under Department of Atomic Energy, and we have two major programs. One is on lasers, and another is particle accelerators. So when we talk of the lasers, means at least we'll find one scientist working in one domain of every domain of the lasers. You can find at least one person working in talk of anything. That's sort of the center is, and we have around 175 plus people working in the laser technology. So that is the biggest hub in the country. And see what happened. Basically, I joined in 1995 RRCAT as a CO2 laser program. That to develop indigenously these CO2 lasers, and subsequently we started focusing on the application part. When it came to the application part, the responsibility of additive manufacturing, at that time we used to call laser rapid manufacturing, was given to me in 2003, and it was my title of PhD also. Like I worked in this area and earned the PhD in 2005. So that's the way that I think I started the things, and subsequently I was abroad in University of Waterloo, Canada, as a research faculty for 2 years, 2007 and 8. And when I came back, and I started full-fledged laser development program at RRCAT in 2009. So from there we started, in a big way, and started building indigenous machine. And our focus was more on developing machine, because we were just thinking, if we buy the machine from the outside, probably recipe will not be available. We may have to deal with the different materials. The requirement will be, and if you want to be leader, because India eventually has to lead the world, and then we are going to be leader in that. So the effort has to be that we have indigenously whole technology in our hand, and that's the way we started, and we are doing the job. Yeah, it's the way we started.
Great, Doctor, for your conscious effort to look at starting something indigenously, that's been something which will also help India in the forefront in terms of going forward, because many of these technologies were 30 years old, but very recently, Doctor, as you did mention about DED, DED is a very new development. How do you think about this technology, and what are the areas of what is the exercise that you have been able to conduct in that space, Doctor?
Yeah, when we started direct energy deposition, first thing we did is at RRCAT, I told you we are developing various type of the lasers. So at that time we had only fiber laser up to 200 watt available indigenously. The biggest thing there is, I went to the management and we discussed the leadership, and then finally I was allowed to buy a 2 kilowatt fiber laser. So that became the first laser in 2011, procured by any research lab for the additive manufacturing application. And then we integrated for DED machine. We built the powder feeder, we built the nozzle, and everything we started doing on and started doing. The moment we built the machine, the biggest challenge I had was how to use this machine. You have now solution, and you are looking for problem now. That's the thing we had. So I started talking with the people, especially in our in-house people, and we found some of the really key components. For example, mesh type spacers. Then we talk of some hexagon plates, which are definitely not the part of the nuclear reactor, something like Deloro 50 bushes, which were very difficult to make it conventionally. So we started working. And what is the biggest thing I'll tell you, Dr. John, was that when we started, we were not knowing what is the particle size we are supposed to use it for our feeders, what is the what is available in the market, how will we proceed ahead. So I mean to say, we started solving problem one by one, and today we have full integrated machine available, and now we are going for the technology transfer, and we are ready to give hand holding to the companies, so that definitely this technology goes into the market, and people of India or abroad can take the benefit of indigenous technology that we developed here.
So, Doctor, since you are also looking at commercially looking forward to getting these machines out, when it comes to technology transfer, have you identified companies who you would be looking forward to working with? And do you think the startup companies are ready for that kind of affiliation going forward, or a partnership?
Yeah, that is correct. One advantage I have is, in 2020, in October 2020, when RRCAT started incubation center, the responsibility of incubation center was also given to me. So, so that is the advantage this particular technology have, since I'm leading that part and this part also. So yes, I started talking with the people informally, and at least I know 4 companies in the country. Some of them already in the additive manufacturing space, and some are likely to join that. So they are interested in taking it up, and since it will be done in a very transparent way how the technology will transfer, considering their business plan, the way they are coming up, and all these things will be discussed with them. And so it is not right time to reveal all the names, but again, I can tell you 4 parties are in the race, and we are on the job.
Okay. And as a center of excellence, Doctor, uh, uh, how is it actually instituting courses in terms of? We also understand the potential of aspirants wanting to learn about additive manufacturing. So, have you also registered any institutional programs, certified programs for additive manufacturing? I'm sure you would have, but if you can
Yes.
broadly explain so that the viewers can also get to learn about
Yeah.
that.
See, in last, if you've seen last 17, 18 years during my PhD, and after that, when we were working on this, we earned a lot of knowledge, and we go on that. The first thing I was, I had a emphasis key, why should not we compile all this information? So first thing I did is during COVID time, when we had a lockdown, the first lockdown time, I wrote a textbook on additive manufacturing, and this book is now available through Flipkart and Amazon. So that it's published by Magral. So this is available now. So a complete information about additive things are given, and we have introduced many chapters. For example, we talk of the systems, and we are talking about the different equipments, and then the qualification criteria, which are normally not the part of the ordinary textbooks. So we have introduced all these parts, and really good one. And once we had this thing, then we started in 2018. We did one short, 5-day course on laser additive manufacturing and technology. And again, we had a plan to do it in 20, but 2021 was the COVID time, so we didn't do that. But recently, we are now working out with IIT Indore to run a certification program. So the incubation center RRCAT and IIT Indore, jointly going to launch a maybe 16 or 20-week program. This will be online program, and after that we'll have at least 1 or 10 days immersion program, so that 1 week and 10 days people can come and see the systems, learn the things, and have face-to-face discussion. So it's not like the program that we have conceived is not only the theoretical aspect of it. Like we are looking for 3 to 4 hours every day, teaching and learning part of it. And later, once the people come here for the 10 days and they or 5 days, they see each other, they understand, and they have complete background ready. So this is going to be a changer, and probably this will definitely bring a big change into the additive manufacturing domain, and people will learn. So that's the way plan we have. Initially, I was thinking to start with the incubation center, but my friends at IIT Indore, they also want to join. So I meant this is opportunity for me also. You have some people who are helping, and so many things are coming together. So really, we are starting with that.
Doctor, and the technology now that you have been able to formulate, and now that it will also come into the market. Currently, are you also offering services, Doctor?
Yes. See, when I conceived this idea to push it into the market, the first question I had, who will buy this technology? Because when we talk of the things, when you are talking of some money investment of hundreds of lakhs, or maybe 1 crore or 2 crore, people are not easy to, they want to have it tested, and they don't mind spending 50% more, and if they have some more rugged machine. So the first thing, that was the big challenge for me. Then I thought of, why should not I start services? So what happens when you have services, then they know what capability we have. The customer client can come, the end user may come and see what are we doing, and their jobs are done. They are testing it. So there are really 2 point advantage of this. Number one, the first advantage they'll see our machine, and they'll have confidence on the machine. Second thing is, if they want to start a business, and suppose they want to go with a new product or some new idea, they can use this facility. They need not to directly spend money, or invest money and then start it. So that came in my mind, and to really help growing the ecosystem within, I'm telling you, evolving the ecosystem within the country, and really it is helping. And I'll tell you, I have spent only 4 months in services, and we have done some 8-9 jobs. I mean, this is really good for us, and giving a lot of satisfaction. The efforts we did, and now the things are moving the way things are being adopted by the market.
Doctor, also now that we know that the national strategy for additive manufacturing is also into place, a conscious effort by the Ministry of Electronics and Information Technology. What do you think, and how do you think that this will actually help in the larger context when it comes to additive manufacturing in the country?
I will say the 2-3 advantage on this, specifically when there is a national strategy on additive manufacturing. The first strategy I see is there is a awareness among the people. When you talk of the national strategy, people know that the government also recognizes it. You have one certified, or maybe established agency saying, this is the emphasis area. We, you, me, maybe talking in pockets, but people may not like that. But when government says, then it's emphasis. And second thing is, when there is a policy, government is ready to invest something, to support the people who are working in this area. So definitely that's going to help in building an ecosystem. And what I say is, once these things happens, probably challenge comes on the technology developers, especially the technocrats and users. Now that they did their job, now how we proceed and do the job. So this is the again thing that I see, and it's a challenge for all of us. And I see a good future, and definitely is going to make a difference in a big way.
Strategically, as you rightly said, Doctor, since the pathway is set, because government's presence and giving that technology an importance also ensures that how the technology can get an industry status going forward. And also collectively, now that we know that there are many companies who are also coming and blooming as startups in the country. Lately, we've also had one session on automotive. The EV as a area of specialization in automotive is being looked at as an option, because OEMs who have huge setup of the conventional subtractive manufacturing methods would probably have one maybe have this additive manufacturing as one in the shop floor. But somebody who is coming with the opportunity and the prospect of design thinking can think of parts consolidation and then build it based on design thinking in terms of the options. So you have a area where you can think beyond imagination in terms of making it more like lactic structure in terms of creating lighter parts, both in polymers and metal. And we've already seen companies already in mobility in electric bikes also coming in this space. So there are some of the companies who are also offering solutions in that area. What do you think in the larger context when it comes to smaller inventory 3D technology can benefit, and how it can benefit these automotive industry now we're very specifically talking about?
Yeah, see, when we talk of the automotive industries, I'll start with the machine builder, from that side, and then we'll move slowly to the, other core. See, almost 2 years back when I was talking with that, and when EV was booming, and there was a pressure in CNC machine manufacture, because now if EV comes, there may not be a lot of machining of the engine parts, especially engines and many parts. So how will they position themselves in the changing environment? So this was a big challenge, and many companies started, working on it, and how they can reposition themselves into the EV market. That's one part. So it shows that, and few of them really thought of, going into additive manufacturing and taking this as a step, and that helped it, right? Second project, as far as the automobile business is concerned, what I'm saying is today the biggest challenge is how fast you can come into the market with your especially innovative idea and with the design thinking, deploying design thinking. And no one wants to be me too product. Everybody wants to first in the market product. That is the emphasis. And definitely when EV domain we talk, lot of opportunities are there, and see, still we have some product into the market, but there are challenges. You see some accidents are happening and so many things. So I'm saying still a lot of scopes are there where people can move on and change the things. And I see a lot of things which can be done with additive manufacturing using plastics, polymers, as well as the metals. And what we are looking for is next level, that is ceramics. So like two of my PhD students are now focusing on the building ceramics. How can you work with them and make it happen? Because once metals are exhausted, definitely you have to go for some other things. And another aspect when we talk of EV and then taking it to that level, and especially when we talk of additive manufacturing, another challenge that we talk of is the making the machines more smart. They have some closed loop control, or they have some features like using AI and ML. So all these things are now being put in. So we are also now trying to have like if you want to have cooling of some dies and molds, or you want to have cooling of some engines, and you want to cool it in certain time, how can you do that, and what is the smart way of doing that? So all these things are now the part of the game which was not earlier. People earlier were doing simple thermal calculations, and based on that they were designing the parts. But now, not only the stationary, but also the transient calculation is a part of the game, and it's people are doing and trying to measure it, and definitely it's going to change the scenario. And when you are doing iterative design, additive manufacturing is the solution today. So that's the way I will like to say.
Yeah, so I think we also see that design is also going to be a key construct for the final outcome of the product. So design thinking is also a part of your course curriculum, doctor, that you plan to do, because
Yes, there is one chapter I have written as on. Then in our course also we have having some 5 lectures, 5 days session. On that 2 lectures every day, and that is on design for additive manufacturing. How should you change your design thinking so that you comply to the additive manufacturing. That's we did, and it's there, and it's only we are conducting during my course program, but also it is also mentioned in the textbook. So both are available, both the places. Yeah.
So, because as the technology grows, I'm sure with more manufacturing units coming with their centers, resource will also be looked at in terms of people coming with the expertise of design thinking for their team of engineers coming with that kind of a thought process.
Yes.
So I think that's the key. Doctor, one more thing. Now, which are the immediate industries and sectors that you are aligning with in terms of offering these solutions when it comes to services?
See, what happened, my emphasis is on the 4 sectors. Number, we are talking of aerospace. We are already talking with the Vikram Sarabhai Space Center. We have joint alliance for almost 5 years. We are working together in different areas. Aerospace is one part. Then second, we are also thinking for defense. We are exploring now, just trying to enter into. Automobile, we are getting some orders for making some small part for the testing. So that is the 3 part. And fourth, definitely our power generation, where we have core area. Talk of the nuclear, and we talk of when you talk of super critical CO2 based Breton cycles, which is the generation 4 nuclear reactor will be using, or you are talking the advanced thermal power stations will be using, or solar thermal energy. So these are the areas, and specifically we are focusing designing some compact heat exchangers, or we are talking of making some channels and tubes. And when we are talking to have some TEG mates, thermoelectric generators, we are also talking of some dissimilar metal joints, specifically how to do the reprocessing part. So all these things are now game, and we have really inquiry from these areas, and then we are also extending services to this. And I'm seeing a very bright future, people who are joining and working in this area, and going to be good for each of us.
And Doctor, now that you mentioned about these sectors, is there a mechanism or a process of standardization that you are actually taking care of when it comes to certification?
True. See, what happened initially, we were working in a research mode. Maybe I'll say almost 2 years back, when we were talking of making the simple tracks and optimization the process, going for the examination. So all these things were the part of this. But if I see in from last 1 years, when you have many things plays, so we have to standardize. You cannot say, because tomorrow client one come and say to you, you do this, and after 3 days, and again he comes and say, you want to do the same, and again you start doing 1 2 3. Is not the solution. So we are starting now doing this. We are building the database with us. We are standardizing the whole component, even the insert part, so that the repeatability and reproducibilities are kept intact. So that is the major part. And definitely, as the published in many research papers, how the machine has to be standardized, what are the criteria for doing all this, we are complying it now and implementing with the machine, so that we have good output of it. Because finally it has to go to the industry, and if you don't bend ourselves, just do the things, then things will be in the lab only. It will never go to the industry. So that is my emphasis.
Very true, Doctor. Also, Doctor, since you mentioned very specific about aerospace, automotive, and defense, these industries, any interest in the medical industry? Because we also see a lot of traction in medical industry going forward when it comes to PSI. Whether this technology that you are actually working on would also cater to that particular area of specialization?
We started working, in the past, we worked with Sri Chitra Trinamal Institute of Medical Science, Trivandrum. And, we did some of the tests, and in vitro and vivo, we passed out. But what is happening, there is a slight deviation for us now today, because, we are doing a lot of metals, specifically, nickel-based alloys and titanium-based alloys, and some iron-based alloys. So we are doing that, and especially we are doing so many advanced material like zircaloy, and then we are talking of silicon carbides and tungsten carbide. Many things we are doing. So the problem, comes as when you talk of the medical systems, you need to have dedicated machine. You cannot have, it has got its own protocol.
Right.
So I this was again, decision one has to take, whether you want to continue with the medical stuff or you want to support other domain. And I realized that key for laser, I think it's much easier to cater larger area today. And then I'm also now thinking to develop EBAM. Already we are discussing on this electron beam based additive manufacturing machine, which is also I'm expecting maybe if something goes very good, then we should be able to indigenously have made it machine available maybe in 2 years time. So we are negotiating now. Design from our side is done, and then trying to work out how to proceed ahead. And everything goes on, and if it happens, then definitely when you talk of EBAM, then the medical devices, implants are the first choice, because impurity issues are not there. You can have very restricted operation or this. So this is on the card. But again, presently I'm just thinking, how can we go faster and spread around, so considering that, in what I'm more focusing on these 4 areas rather than the medical. But it is not that we do not have interest.
Good, doctor. I mean, it's a good initiative. You have already visualized, and you also have the vision to look at that option. So, again, it is also the resource and the team that you need to build to get that kind of a prospect. Because, yeah, EBAM, when it comes to orthopedics, there is a lot of traction that electron beam manufacturing can get. When it comes to femur implants and also, acetabular cups, there are a lot of companies who are, who are already there. RCAM is one company, if you know. So
Yes.
similarly, if we can have something very indigenously, we are also looking at a time where democratization is the key to see that how these technologies can penetrate and it can benefit everybody, and also for the good work that you're already doing, doctor. Institutions like you are really of high regard, because there's a lot of efforts being made in terms of research and then coming out with these products. And really appreciate your effort, doctor. You've been working hard in this space as a researcher, and also coming up with these products. It takes a lot of effort. So thank you so much for your time, doctor.
Before I end, I'll say that it's not me. I just was visualizing and maybe working in the lab, but whole team. If you talk of my team of 15, 16 people, and we are lucky in Department of Atomic Energy. In one way, because I'm also faculty for Homi Bhabha National Institute. I'm faculty member there. So I'm having 8 PhD students working with me. So I'm lucky. And you have one permanent staffs who are managing the show, and you have a one running flow of water. The students coming, spending maybe 12, 13 or 14 hours every day and going the job. And when you see working with the young people, we also feel more energy, and think of spending times, especially weekends, at least coming for 5-6 hours and spend with them, try to do that. So all this energy, and I'll say that when everything is synchronized, the young guys, then old people with experience, the facility, the infrastructure, and then last the opportunity, and definitely making a joint program so that everything gets synchronized and we get the good output. So definitely I'm indebted to my team who really helped me, and my leadership who trusted me, the management who supported, and all around. So all these things is not only me, all around, we have now ecosystem available, which really help for
Right.
this product to come to the market. Yeah.
Definitely, doctor. But where I'm also coming from is you need a person to stand there strongly because the passion is very, very important. When you stand there strongly, you have everybody gathering, to support and take the things forward. So that's and really commendable achievement, doctor. And I'm sure there's much to reach in terms of heights, but I think the pathway is set, and also to your team, because you've been really working in that direction. So thank you so much, doctor, for your time, and I hope to connect with you soon personally also, because it was always an opportunity with this virtual space. But yes, thank you for your inputs and your insights, and all the best, sir. Thank you so much for your time.
Thank you very much. Thank you.
Thank you, sir. Thank you.